Hello and welcome back. Today we have a very special equation. I'll name it. This type of question, it has come up on sort of like step. It has come up on a the very same one, of course. There's different numbers, and you need to recognize it. What is special about that? First of all, it's a polynomial equation, and the coefficients are symmetrical, without anything missing. So 6, 6. 25, 25. And of course, if we have left with, if we had two left in the middle, it should be exactly the same. But here is only one, so it doesn't really matter about this 12. And in its easiest form, all the signs kind of match. Here we have the anomaly, a minus on the 25 and a plus. So this is an additional pain. So I picked up the more general version, so just to get us to think a little bit. But it's not a big problem if that happens. Okay. The first thing when you have this type of symmetrical environment is actually to divide the equation through by the highest power, perhaps not the highest power. We need to create something which is symmetrical still. So this power here is the key, because if you divide by x squared, what will happen? And of course, x squared cannot be 0 quite clearly, because 0, 0, 0, 0, 6 is not equal to 0. 6x squared minus 25x plus 12 plus 25 over x plus 6 over x squared is equal to 0. The next step after that, once you've done that, is to group the terms. So if you look at, it's like a similar technique to when you're using complex numbers in some type of question. In fact, I think that can be done. This type of question can be done with complex numbers, but the algebraic version is in fact a lot quicker. You don't actually need complex numbers and putting all sorts of things in. So we're going to group in pairs these two terms. So 6 are factorized out, and this is going to be an x squared plus a 1 over x squared. So this is the leading term and the last term. Then I'm going to put the x and the 1 over x, and the way it's written in there, I'm going to factorize a minus 25, and I'm going to have it as x minus 1 over x. And of course, we got the plus 12 is equal to 0. And that's what I meant. If we didn't have this minus or pluses, there'll be plus there, which makes life easier. Now, this type of things, when you're having squares, x squared plus 1 over squared, come from the expansion of x plus or minus 1 over x all squared. If you see what happens in there, you're getting an x squared plus this squared plus or minus that 2 lots of that times that. So that's in fact a plus or minus 2. So depending what you got. So at the moment, the one that we want to use in here, I don't know if you can see it, is the one with the minus, because we have, let me just remove it so you can actually see. If we call this particular quantity something else, let's say we call it y, so that's y squared. Y squared is x squared plus 1 over x squared, and let's put the 2 to the other side. So 2 plus y squared. Okay, so this equation will transform to 6. This quantity is, of course, y squared plus 2 minus 25 lots are called this particular thing. I should perhaps write it up here. X minus 1 over x equals y. Y plus 12. This would have become, of course, much more complicated if you had, of course, something cubed. There's a lot of more tedious algebra. To have had something cubed, you would have needed, of course, another 2 terms there. So it would have been x to the 6. So it's not likely you get an equation like that. Okay, what happens now from this line here? We can multiply it out. I don't know who's in my door. Very annoying and very inconvenient, but I'm not going to answer it. So we got 6y squared plus 12 minus 25y plus 12 is equal to 0. 6y squared minus 25y. And the 12 plus 12 is 24. I don't know if that factorizes. I'm not going to use a calculator. 25 squared is 625. 4 times 6 times 24. 24 times 24 is 576. And 576 subtract from that is 49. So we'll know triple. So it does factorize. And I'm going to use the quadratic formula sneakily. So it's going to be 25 plus 7 divided by 12. You can use whatever method you want. So that's 32 divided by 12. Divide top and bottom by 4. 8/3, one of the solutions. So this factorizes to 3y minus 8. And the other one quite clearly is going to be 2y minus 3. So let's just double check that it does work. Positive 24 minus 9 minus 16. Yeah, it does work. So we have actually worked out so far some kind of quadratic, some auxiliary quadratic in y. I don't need this apart from what y stands for, and y is been left on the top up there. So I have two possible solutions. So y is equal to 8/3, or y is equal to 3/2. But of course y stands for x minus 1 over x, 8/3. X minus 1 over x is 3/2. Solve each of these quadratics. So now there's going to be more quadratics. So it's going to be times it by 3x. So I'm going to get the 3x squared minus a 3 is equal to 8x. 3x squared minus 8x minus 3 is equal to 0. And this would factorize this at 3x. I can see this one just about 3 on this side, and we need 1 minus and 1 plus. So we need more negatives. That's the negative, that's the plus. I'll sort out the solutions at the end. This one we need to multiply the equation by 2x. So we're going to get a 2x squared minus a 2 is equal to 3x. 2x squared minus 3x minus 2 is equal to 0. And does it factorize? I hope it does. Yes, it does. So 2x, x, 2, and 1. 1 plus and 1 minus again. So this particular one is going to be a, we need more minus, so that's the minus bit, so that's a plus in there. And we have 4 solutions, which I'm going to list them. And it's minus a 1/3 from this bracket. I lost the equal to 0, of course, in there. Then it's going to be a positive 3. From here, we're going to have a minus a 1/2. And from here, we're going to have a positive 2. So this is how you solve this type of equation. I have loads of them in my books. Maybe, I want to say loads, I mean 5 or 6. They become tediously boring once you've done a few. They all work exactly the same way. And it's nice to have seen this type of equation. I mean, I know many of you have actually seen, but oops. It might be a new thing for some of you. Okay, I hope you enjoyed the video and I hope you followed it. I'm going to be signing out, and I'll see you very, very soon with more videos on maths. Bye for now.